So this is the question, a question about melting points and bonding and structure. So I always like to set them out where I'm giving myself some structure to this. It's showing you the melting points of three substances, and we can see straight away that one's ionic and two are covalent. We can see the different melting points, and we know that this one's going to be a high melting point because this is an ionic substance. These are much lower because they're covalent. We can explain about the intermolecular forces that make this different. But then we've got a bit of a difference here, and we're going to have to explain that difference. So as it says here, explain why the melting points of these substances are different, and you need to refer to the structure and the bonding in each substance. So I'm going to set this out, and hopefully you can see how it relates to the question. Okay, so I split this into three. I've split it into bonding because it's asked about bonding. I've split it into structure, and that's the forces that are between the ions or between the molecules. And I've got to compare the melting points because I'm going to have to do some comparison to explain why these are different. So in the first one, so we can say sodium chloride is ionic. Okay, and it's a giant ionic lattice, but it's ionic bonding, and it's intermolecular forces, strong intermolecular, sorry, not intermolecular, that will get you no marks at all. It's strong electrostatic forces between oppositely charged ions, which I can put here, or I can put here because they're the forces that are causing this structure. So it's ionic bonding, and it is a giant ionic lattice. If I look at Cl2, it is covalent bonding, and that's going to give rise to a simple covalent molecule. Okay, so we've got to be careful with how we describe these. And the next one is at HCl, and we've got covalent bonding, again, between the hydrogen and the chlorine, and that is also a simple covalent molecule. So what can we say about the structure itself? Well, we know it's the sodium chloride is a giant ionic structure, but how is it giant ionic? So you've got strong electrostatic forces of attraction between oppositely charged ions. Okay, so I've written that in. If we look at chlorine, chlorine is not it's subject to van der Waals forces, so it's got weak van der Waals forces, so van der Waals forces, and that, if we remember, is between molecules. Okay, so they're going to be, in our heads, we're thinking, well, they're going to be easy to break. And for the hydrogen chloride, we've got, there's always van der Waals forces in any molecule, but with this, we have got a dipole. So this is a permanent dipole. Dipole force. And that's what's going to keep those together. So you've got dipole forces, I'll say, of attraction. Okay, so we've explained then about the structure, the bonding and the structure. We've explained how they hold each other together, they're held together. So in sodium chloride, it's strong electrostatic forces of attraction. In chlorine, you've got weak van der Waals forces, and with hydrogen chloride, you've got a permanent dipole force of attraction. So if we compare the melting points, what we can see from up here, that the ionic bonding is much, much stronger than the other two types of bonding, because it's going to take a lot more energy to melt our molecule, and so the melting point is much higher. And we can write that below. But what about between these two? Well, we can see whatever the bonding or the forces of attraction are in chlorine, they are much stronger than the forces of attraction in hydrogen chloride because the melting point is much higher. So we can say that between chlorine and hydrogen chloride, the van der Waals forces of chlorine are much stronger than the dipole-dipole forces of attraction in hydrogen chloride because the melting point is higher. Okay, so I've written the ionic bonding in sodium chloride is stronger than the van der Waals forces in the dipole-dipole forces, which is why the boiling point is so high. Then we have to describe the boiling points between the chlorine and the hydrogen chloride. So the van der Waals forces in chlorine are stronger than the dipole-dipole forces in HCl. So hence the melting point for Cl2 is higher than HCl. And I guess if I want to make sure I'm going to get the point, then I've got to be specific. Looking at the, and that I would have said that was absolutely fine. You've shown a progression from talking about the bonding through to talking about the forces to then comparing the melting points. And that would get you 6 marks. There is one other statement in the mark scheme, and it's about the size of the hydrogen chloride compared to the size of the chlorine. The chlorine is bigger than the hydrogen chloride because the chlorine has got more electrons, and how that affects anything is just really about these dipole-dipole forces and these van der Waals forces. It has a bearing on that. However, if you didn't put that in, it's not going to lose you a mark. That is just an additional extra. So the question that we've got here, the answer that we've got is going to get you those 6 marks because you can see progress through your answer and it's in a logical fashion.